Hey guys, so today I'm here to talk to you guys about DNA synthesis, and more specifically about the lagging strand and the leading strand and the difference between them, and how things are, or how the base pairs are added onto it and synthesized and so on. I'm going to do this because when I was studying for this, I was super confused and I had no idea what was going on. And I found that there weren't many helpful resources. Like, there were a lot of resources that talked about it, but it still never was completely clear for me. I was always confused on how it's synthesized, and I would get confused with the 5' to 3' direction and things like that. So I'm making this video so that you guys don't have to go through what I went through. I understand it pretty clear now, and once you do understand it, it is pretty easy. It's just, getting your head wrapped up around the concept, and once that's done, then you're good to go. So before I actually go on illustrating the whole process, there's a few key ideas that you have to remember and keep in mind, and they're really easy. So basically, a DNA, so let me start with this one. A DNA is made up of a bunch of nucleotides, right? So you have just like bunch of nucleotides. Okay, and so these make up the strand of a DNA. What are nucleotides made up of? Well, it's made up of a phosphate group, a sugar, and a base. So those are your ingredients to a nucleotide that makes up a DNA, if you're ever cooking in the kitchen. Yeah, so that's pretty easy, right? There's not much to it. So now that you know that, let's move further and get you to understand that DNA is anti-parallel. I don't know if it has two L's or whatever. Well, sorry if I spelled that wrong. Anyway, so it's anti-parallel, which means that if you have a strand moving in one direction, the other one is going to be moving in the opposite direction. Okay? So if this is my DNA, one is going to be moving this way and one is going to be moving down. Alright? So that means it's anti-parallel. Now, to further understand the whole concept of DNA and anti-parallels, you must understand that one of them is always moving in a 5' to 3' direction. And since it's anti-parallel, that means the other strand is going to be moving in the opposite direction. So this strand is going to be moving like this. So if this is moving from 5' to 3', this is going to move from 3' to 5' kind of thing. So imagine if this is my DNA strand and I have my base pairs attaching each other. So this is one strand, this is the other, and this whole thing makes up a DNA helix, right? So if I have one strand being a 3', the opposite strand is going to be the 5', alright? And so that gives you an idea of the anti-parallels. Okay? So hopefully that makes sense. And yeah, so it's pretty straightforward, right? So 5' to 3' going up, 5' to 3' going down. Anti-parallel. Okay, so now that you know that, we'll go over the actual concept of, the leading strand and lagging strand. So, imagine I have my DNA helix. Okay, so that's my DNA helix. And, I've got my base pairs going on over here. This obviously isn't very accurate, but you know what I mean. So this is my helix, and at one point when I'm synthesizing, it's got to open up, right? So let's say it opens up like this. Okay? Now what opens it up? Okay, so let's say this is my helix and it's just opening it up like that. Now what is opening it up is this little clamp. So it's like this little clamp structure that comes on here. And what that is called is a helicase. So this is a helicase. And so a helicase is basically It's a helix breaker. So what's happening is, here, I'll put it down as a helix breaker. And what's happening is that it's opening up the helix. Okay? So it's breaking open this helix, and it's just coming through here and just breaking it open. Okay? And then what happens is that we have these little structures, these little guys over here, on the individual strands that have been opened up. And what these are called are single-stranded binding proteins. So SSBP for short, single-stranded binding proteins. And what single-stranded binding proteins do is they protect the DNA from cleavaging, right? So they protect it from cleavaging, they prevent it from rehealing, and it protects it from deprivation. So it's stabilizing the opened up helix as well. So these guys are really, really important. Okay, so while the helicase is opening up the helix, the single-stranded binding proteins are keeping it open. Okay, so I'm just going to simply write keep strands apart. I'm putting this in really simple terms so that it's easier to understand. Okay, so yeah, so hopefully that makes sense. Now, the next thing to know is that, like I said earlier, these two strands over here are anti-parallel. Okay? So, if this is 3', then this is going to be 5'. And since this is 3', this has to be 5', and this is going to be 3'. Okay? So they're anti-parallel. So that makes sense, right? Now, another thing you have to know is that when we're adding base pairs, so we're trying to make up a new DNA. Imagine this black strand, this black DNA is our parent strand. And we are trying to add base pairs and make up a sequence so that we can convert this into a daughter, so we can recreate a daughter strand. Okay? So the way we do that is that the strands are always built from a 5' to 3' direction. Okay? Now this is the part that gets a little bit confusing to most people. Since it's built from a 5' to 3' direction, let me write that down. So DNA is always built from a 5' to 3' direction. This means that you add nucleotides onto the 3' carbon. Always. You add it onto the 3' direction. Okay? And this will make a little bit more sense in a second. So, let me start over here on this strand. So we have to build nucleotides on this strand and this strand so that it makes a new helix. So let's start from this top one. So this is a 3', this is going from 3' to 5', right? So, like I said over here, DNA can only be built from a 5' to 3' direction. Since DNA is anti-parallel, if this is, let me do it in red, if this is my 3', then I'm going to have a 5' being built, right? Because it's always built anti-parallel. So, since this is 5', it's being built onto a 5' to 3' direction, right? So this means that it's being continuously built this way, non-stop, okay? And it can do that because it's adding, so you're adding nucleotide to the 3' direction, and you're building it from a 5' direction to a 3' direction. Okay, so hopefully that makes a bit of sense. So, you have 3' to 5' being parent strand. The daughter strand is going to be built anti-parallel, so it's going to be built from 5' to 3' direction. This, whenever it's being built continuously, since it's going from a 5' to 3' direction, it's being built continuously, so that's called our leading strand. Okay? So that's our leading strand. Now, here's where the confusing part comes in, if that wasn't confusing enough. when we look at this bottom strand over here, this is going to be a little bit different, because now this strand is going from a 5' to 3' direction. Now, DNA can only be added, or DNA can only be made from a 5' to 3' direction while it is being added to the 3' DNA strand. So this is a 5' DNA strand. So I can't add it going this way. I can't do that because then I would be adding it from a 3' to 5' direction. And I said over here, it can only be added from a 5' to 3' direction. So that's a problem. We can't do that. So instead, what happens is, as my DNA is opening it up, as my helix is opening up, if this is my 3' direction, I add sequences going this way, right? I add it going this way, the opposite way. So this one's being added this way, this one's being added the opposite way. And that again tells you that it's anti-parallel, right? So now it's being added from a, so if this is 3', it's being added on a 5' over here to a 3', and then you have a gap, and then again 5' to 3', and then you have another gap, because as it's opening, so imagine this opening it up, I add it here, and then it opens more, so I have to add more here, and it opens and I have to add more here. So all the while it's adding in an opposite, it's adding discontinuously, okay, it's a discontinuous synthesis, because as the DNA opens, I have to keep adding more, and I can't add it one after the other, because if I'm adding it going this way, this opens up, so I have to come back and add more this way. Okay? So this tells us that this is the lagging strand. Okay? Hopefully that makes a little bit more sense. Just to further clarify, so since these are going to be little segments and then we're going to have gaps in between, these little segments of DNA are called Okazaki fragments. Okay, so those are just the fragments of DNA, because as this is opening it up, as this DNA is opening up, I have to add more sequences and add more sequences and add more sequences. And then in between, I'm going to have gaps. So each sequence is going to be an Okazaki fragment, and then these gaps are going to be nicks. And so, you know, later on in the process, polymerase comes in and, you know, seals it up or you know, attaches them together, and it's a whole nother video that I have to make for that. But hopefully this clears up the whole concept of the leading strand and the lagging strand. So from this video, the take-home message for sure is that DNA is anti-parallel. The parent DNA is anti-parallel, and the daughter strand that is being made is anti-parallel. Okay? And that DNA is always built from a 5' to 3' direction. Therefore, you can only add it onto the 3' direction. Okay? Hopefully that makes more sense. If you feel like things are still not clear and you need me to clear some things up, please leave a comment or message me and let me know. I would love to clear it up, and if you have any suggestions on how to make the video more useful, please let me know. And yeah, so I'm open to suggestions, I'm open to questions, and hopefully this makes more sense, and this was a useful video, and thank you for watching. Good luck on your exams.